Hello everyone, welcome to Math with Allison. Today we're continuing our series on derivatives. If you haven't already, make sure to check out some of my previous videos. Click that little eye in the corner and it'll get you there. Otherwise, today we are specifically talking about e to the power of x along with e to the power of kx, all that stuff, yada yada, and what it does. So let's go ahead and dive into it. Here we are going to start with a limit definition. We're going to do some work in order to get to the shortcut. So we appreciate it more. So let's go ahead and look at this. I'm going to fill in what I know here. So I'm going to plug in the limit as h approaches 0. And here I'm going to have e to the x plus h minus e to the x, all of this over h. I'm going to go ahead and rewrite this. So I notice here that both of these terms have an e to the x. Since that e to the x has nothing to do with h, and we're taking the limit as h approaches 0, then we can actually pull out that e to the power of x. So when something has nothing to do with our limit like this, we can pull it out. So here I'm left with e to the h minus 1, all divided by h. So there's lots of math that goes in behind this limit, but I want us to look at it visually. So I graph the function e to the x minus 1 over x because Desmos doesn't like the letter h. So pretend that the x is an h. And we want to take the limit as x approaches 0. So as we approach 0, what happens to our function? I'm going to zoom in real close here, and I can see my actual function hits a value of 1. So this entire limit is actually equal to 1. So if I were to rewrite this, I just get e to the power of x. So this is the limit definition. We found that the derivative of e to the x is actually just e to the power of x. There's no change to it. So what happens though if x is not the only thing in the exponent? So let's go ahead and take this example right here. We have f of x equals e to the 3x. Well, we have a little rule here that we're going to use. Whenever we have the derivative of e to the kx, where k represents any number, that k comes down and we keep everything else totally the same. So if we use this rule, then the f prime of x of our function is going to be 3 times e to the 3x. So that seems very abstract. I like to think about it as a triangle. So I have a little triangle I'm going to write out here. As we take the derivative, what happens is first we drop down the original function. So I drop it down, but I'm going to multiply it by the derivative of whatever the exponent is. So in our case, that's going to be the derivative of 3x. So the derivative of 3x is going to be 3, and then we multiply it by e to the 3x. I really like this triangle method, and it actually helps us quite a bit with larger exponents. So let's take this example, f of x equals e to the x squared plus 1, all of that in the exponent. The little triangle tells me that first I'm going to drop it down, so e to the x squared plus 1, but I'm going to multiply it by the derivative of the exponent, which is x squared plus 1. When I take the actual derivative of it, I get the derivative is 2x, and I multiply that by e to the x squared plus 1. And that's all we got to do. I have a rather large example right here. So e to the negative x cubed plus 2x minus 1. If we use the triangle method, I'm going to skip some steps here, but at first I'm going to drop it down. And now I'm just going to directly multiply it by the derivative. So I'm not going to write it out this time. If I take the derivative of that entire exponent, I get negative 3x squared plus 2, and then that 1 turns into a 0. And so I immediately get the derivative. So that's all I have for us today on e to the power of x. This is going to be a short little video, but if you enjoyed it, please leave a thumbs up and comment other types of problems or other content you'd like to see done. Thanks for watching.